Hello good people, I'm Visa from Recyclop Studios, and next on our circuit bending series, XH-322A piano. Okay, so here it is. Very simple keyboard. 2.5 octaves of keys. There's, in theory, two sounds that sound pretty much the same. There's some pre-recorded songs. There seems to be some kind of mic input. Not sure what it does or what you can do with it. And there seems to be some kind of store thing, though the store mode seems to be playing the pre-recorded songs. There is a clear button, but I haven't been able to clear anything from the store, so not sure how it works. Anyway, just a quick sample. I need to press the keep the batteries so that we can. Very gnarly, simple sound. It's monotonic, one sound at a time. High priority. And yeah, there's some volume control you can do, not much. And yeah, the two sounds, other one is pretty much the same. And yeah, this power input as well. Probably works better than the batteries without the cover. And so, yeah, I've done only one mod, check out. I'm not sure if I found the frequency resistor or if I just had no time to do anything with it, but let's see. Let's crack it open and see what we get. Comes right open after these screws away. Again, bottom side is only the battery pack and everything else is on the cover. Let's see if I can put them something. Key, yes, still working. Yeah, not the most firm design, but it works, and one can probably do quite fun things with it. Possibly. We'll see. Anyway, what we can see here is there seems to be a resistor array that defines which key is being pressed. Maybe it would be interesting to take it open and see what it has. Let's do that. Yep, as expected. Other end of the resistor array is here, and the other end is the metal plate. So from here to, if you press here, then there's all the resistors in series and the maximum resistance. And if you press here, then it's basically sorted. Very simple design. Interestingly, the resistor values are not the same throughout the array. It's probably carefully calculated because it's fairly well in tune, even though they are fixed resistors. I'm a bit surprised how well it is tuned. I haven't checked if it's in overall in tune, but if it's not, then a potentiometer added to the end or here in series anyway could help. Possibly. Okay, next, well, here's the blob. Interestingly, there's a separate circuit here. I would guess these are only for the switching and those functions. Oh, there is one resistor. One would guess that this is the tone resistor. A little bit of water. It went dead. No, I'm not getting any. But yeah, basically one should be able to It's terribly loud, at least I can say that much. The jack is in parallel and a quite bad solder joint there. Somehow it would make sense that this is the clocking resistor, but it doesn't seem like that. Let's see where these... Aha! Maybe this is only for the pre-programmed songs. And there's another blob in here. Let's have a look. No blobs here. But it could actually be a simple analog synthesizer. There's quite many components for a so simple thing. Yeah, that could actually be it, because the sounds are very simple that come out. So my guess currently is that this blob is only for the pre-programmed songs, and this is a analog synthesizer. That could be it. Would be interesting to reverse engineer this and see how the connection diagram looks like. Okay, so I've now spent 2 nights and a half day reverse engineering this, mainly this board here. my process here was I took a picture of it, of the main board, and printed it out. Then I marked where all the wires were going, or where I thought they were going. I hadn't yet opened up these, so I didn't really know exactly. Then I marked all the components on this bottom side, where this is one-sided PCB, so all the traces are on this side. So I marked all the components that were on the other side, and after that I did a kind of rough sketch of the schematics. This looks really nasty, but I just went on so without any further thought of what's happening there. After I had done that, I started drawing more of a cleaner version of the schematics. Already putting in some thought to it, and what there is, and so forth. And from here I noticed the kind of blocks that it's built from. I noticed that there's for the microphone input there's a mic pre, there's the oscillator, and there's a output stage or output amp, and there's the separate PCB for the program sounds. As a last thing, I started drawing clean these blocks that I've noticed. There was so the mic pre, very simple single transistor or JFET. I don't really know what it was. Topology. If you Google simple mic pre, you get something like this. What's very odd in here, on pretty much everywhere, is that everything seems to be kind of reversed. So on most of the simple mic pre schematics, the mic is against ground, but here the mic is against the 6 volts. But I don't think that has a too big of an effort, because it has resistor here, that's so it's kind of creating a voltage divider. Well, I suppose it will do the job as well. Anyway, then here's where the sort of main magic happens. It's still not very clear, but I hope we can get in some understanding here. We can leave off this part fully and concentrate in here. And what it appears to be is something that's called often astable multi-vibrator, or a 2-transistor oscillator. Anyway, what we have here is 2 transistors that form a kind of mirror of each other, except the bases are connected to the other oscillators. I think it's usually emitter through a capacitor, and the same for the other one as well. Sorry, this was also reversed as well. Normally, if you Google the schematics for this, it's the caps are connected to the collector, and from there each kind of node there are resistors to the on this one there's resistance to the ground, and normally it's resistance to the operation voltage, whatever you have in this. So, but yeah, I'm quite confident this is what's happening here. It's just reversed so that it's against ground rather than the 6 volts. But it seems to be working. And then there's some functionality that has been added there. Well, first of all, for some reason here they are having 2 fixed resistors in series, where they could have used only one, but I think the PCB might have been designed for other uses as well. So anyway, they use two in series. On the other side there's only one, but here in the middle happens something interesting. First of all, this is there's the string of resistors, so the keyboard is basically here, and as we already saw, if you press key here, it will connect this point to that point through these resistors. So it's kind of like a potentiometer or variable resistor, but it's in the steps of the keys. So that's a string of resistors against ground, and on the other side there's one fixed resistor against ground, but there's also a parallel resistor through a switch to the ground, which connects obviously the either disconnects the resistor or connects, and that's called the, I think it's called tone switch. Yes, tone A and tone B, and it slightly changes the sound of it. It might be acting kind of like a wave shaper of sorts. I'm not too sure, but yeah, that's my best guess will happen with this. And then I didn't draw it separately, but we have the kind of output stage. There is this point in this circuit is kind of like the kind of mixing port or trace. It's taking the signal from the oscillator, and it's taking the signal from the mic pre to this, and it's also taking the signal from the program board. But I noticed that there's a switch called play/store. Let's see what's it called. Function. Yeah, play function and store function. And what it does, it flips the ground either to the program PCB or to the microphone pre and the oscillator circuit. So this basically selects if you want to play the pre-recorded songs in the blob, or if you want to play yourself and sing. So that's what that is doing. There's a power switch, which is just cutting off all the ground from the whole circuit. There's volume. This is interesting. It's just a bypassing a resistor in series with the speaker, which is, well, there's lots of very simple things that has been done here, and yeah, that's one of the way. So even though it's a kind of like a slider, it's a switch, chip limit switch. And yeah, and there's a transistor or JFET or some kind that kind of gives the power to the speaker. So yeah, but what was made things difficult was that there was 5 components that three-legged components that looked like transistors of some kind, but they wiped away all the writing on the components, so you couldn't really tell what they are. So there's good pile of guesswork here. But yeah, just comparing to what the common circuits are for these functions, then you can kind of guess what the components are and which are which leg as well. The whole thing stinks cheap, which is partially fun for especially circuit benders, that we get to do all kind of fun stuff. Anyway, now that I have a faint understanding, oh yeah, I noticed also that the earlier this resistor next to the blob, so or actually the whole board, I came to a conclusion that it's not using the oscillator on this board to produce the sound, but it's producing the sound itself. And this resistor here, as I earlier was guessing, it is the clocking resistor, but it's only when you listen to the pre-recorded songs. To retune this oscillator, you would probably, well, there's many ways to do it. If you want to scale the whole or tune the whole keys, I would probably take one of the resistors. One of these resistors are on this main PCB. Can't remember which one it was, somewhere here. I would probably solder that off and solder in place a trimmer potentiometer of maybe, I don't know, twice the value of this. So then when you're in mid position, then it's roughly the same as it is, and you can kind of tune the keys to plus minus something. That's one way of doing it. What I was thinking of doing is that I take I first of all cut this wire off, add a switch of which the other pole will connect to the keys, and the other pole will connect to a Vactrol. So Vactrol is a LED and a light dependent resistor put in I do them with black heat shrink tube. So they are facing each other, and basically they are converting a voltage to resistance. And that resistance I'm planning to put just over the whole key resistor array. So, and what this does is that when you flip the switch off from the keys, it will turn off the keys, and it will turn into the control voltage input jack that I will probably drill here somewhere. So I can play this instrument from the modular synthesizer that I built there, or sequencer on it, more specifically. Other thing I was thinking of possibly doing, or testing at least, is to replace this tone resistor with another Vactrol and have a CV input to change the sound of the synthesizer. One could maybe add another switch to it and have it completely on a CV input, or replace either of these with the potentiometer and have hand adjustable. Yeah, there are many ways, but I was thinking of having it so that the tone, let's say tone A, is still the same, and the tone B will be controllable by a voltage signal to the jack that I will drill somewhere back in there. And yeah, those are the only ones that I've come up with so far. And yeah, I will of course add a resistor in place, potentiometer in place of this resistor, so I can mess up the songs in there as well. One thing that could be done is replace this volume with an attenuator. So potentiometer, one leg to the ground, middle top leg to the signal input, and the middle goes to the load or the speaker and the line out in this case. But yeah, that could be one thing that would be interesting for here in here, especially since this volume is it doesn't really affect much. This is surprisingly loud thing. So, and especially since the jack output jack is not disconnecting this speaker, so it's in a loud volume every time. So yeah, I'm not really sure why it's not working. It could be something to do with this transistor or JFET or whatever it is. And not having, yeah, I think it could be since there's just a transistor output by itself, and it's running through the speaker to the ground, and if you disconnect the ground and in place of that you have a input of a device that's most likely buffered in a way, so high impedance, then the current is not flowing to the ground. It's not flowing anywhere, and that's why the transistor is silent. That would be my guess. Maybe some people that are wiser than me can say how it really is, but I think that's what's happening. So it could be possible to make it working by adding Relatively high ohmic resistor from somewhere here to ground, maybe, so that there's always some load to the resistor, to the transistor. That might work. Actually, probably from here, so that there's effect of the volume. Yeah, those are roughly the ideas that one could do with this thing. Oh, maybe, yeah. Creative minds can think tons of other things that one could do, but these were the things that I thought of doing in this case. But yeah, let's see what comes out, and yeah, let's see if I do it off camera or on camera. You'll see. Okay.